Okay, so way to go. Most of you did it. And so I hope that helped you, right? So keep these ACs somewhere, right? I would keep them somewhere together, right? All the ACs for this unit, so you kind of have something to review. So we've got a soccer club here. There are 3 different shirts and 2 different pairs of shorts. Create a visual representation indicating the outcomes. You can do a tree diagram or a table, it's up to you. It doesn't matter which one you start with. If I go with the shirts, yellow, red, and green, and then you've got 2 different choices for shorts. So black and white, black and white, black and white. So that would be it. Okay? How about this? We give you 1 mark for the first, and then another mark for the second. So 2 marks. Just read it carefully. Create a visual indicating the outcome. So this would be it. If it asks you for how many outcomes, you'd have to say 6, right? So you can go 3 times 2. There's 3 shirts, 2 shorts, 6 outcomes, just to cover your bases, right? And if you did a table, that's fine. But there's 6 branches, so we know we have 6 outcomes. Next. Question? Marcy owns a store, and it needs a 5-character order number. The core code starts with a letter and is followed by 4 numbers. There's an example. So, given that repetition is allowed, letter, these are all numbers. So it's like an event, right? So there's 26 letters, and the numbers each get a 10, right? So this would be 26 times 10 to the power of 4. That probably save you a little bit of time. And so that's 260,000, okay? 260,000 codes that can be generated with that format. How many different order numbers are possible if no repetition is allowed, right? So we've got letter, and then all of these are numbers. We know that we have 26 to start. We're not using letters anymore, so I don't need to worry about them repeating. Yeah, 10, 9, 8, 7. I will today introduce a shortcut for something like this. You may still use this method, but I will show you permutation notation, which you can replace instead of having to do this every time. Okay, just giving you a heads up. This gives you 131,040 numbers. Okay, 1 mark. How many different order numbers have at least 1 repeated character? I'm giving you a hint, right? Use A and B. At least 1, think of it this way. Maybe this will come in handy now. Your universal is all of these, right? 260,000. That's all possible codes that we can generate in this scenario. In here, in like a subset that you've created, these ones have, let's say, no repeats. All of the passwords in there are no repeats, which is 131,000, right? Oh, sorry. No, I'm mixing it up. The machine was distracting me. Honestly, I had a hard time thinking. I don't like loud noises. No repeats are out here. That's what I tried to say. No repeats are like your outliers. At least 1. There it is again. At least 1 is like your sets, right? All the sets that we're talking about, those are your at least ones, right? So to get this, what do? We go universal minus outliers, right? That's how it goes. So we're going to go at least 1 repeat would be universal minus no repeats. So you should write this down if you haven't figured this one out. And no repeats is 131,040, right? So if you take your universal and you take away the ones that don't have repeats, then you're left with whatever is in those sets. And so this would be 128,960 codes. Have at least one repetition. At least one. So it could have more, right? Yeah. You went straight to here? Or like here? Oh, absolutely. That's fine. Yeah. No problem. Because, and I have to tell you this, this is what the province is going to do. If you're using numbers that you've done, that you've already computed before, it's just worth 1 mark because you're just subtracting. If this would be the question, like if they just threw this at you, this would be worth 2 marks. Okay, because you would have had to figure this out, you would have had to figure that out, and then subtract. So let the marks indicate to you how much work is needed, okay? Let's keep going. Marcy liked to assign the letters E for express and R for returns. She generated, how many can she generate if it starts with an E or an R? These are cases. Assume repetition is not allowed. You may do this if it starts with an E, okay? If it starts with an R, so this would be 1 and 1. This would be 10, 9, 8, 7. 10, 9, 8, 7. So you get them both separately, which I didn't do. And so that's 90 times 56, right? That's 5,040. 5,040. If you combine them, you get a 10,080 codes or order numbers, okay? Or, right? Or you could have just done this in one shot, knowing that this is ER. Hopefully we don't have to go there. Then this is 10, 9, 8, 7. So remember, this is just one slot. It just takes away one at a time from whatever you have left. But this doesn't really affect these slots here because they're not letters. So you get the same answer regardless of how you approach it. Where are the 2 marks coming from? I would say you get, in my books, you get 1 for having the ER case, whether you do it this way or that way, and another mark for actually computing it and getting your final answer. Marcy realized that using the letters I and O create confusion. How many order numbers are possible if these are removed? Repetition is allowed. So I just need to remove the 2, right? 26 minus 2 to get the 24. And then this is 10, 10, 10, 10, okay? So that'll be 24 times 10 to the power of 4. That is 240,000 codes or order numbers. Okay? Marcy received so many orders that she needs to be able to generate more codes. Suggest one change that she could make to increase the possible number of codes. What could you do? Have more values, right? Like have, instead of a 5-digit code, give it a 6-digit code, right? Yes. I thought you were going to give an amazing answer, Philbert. Go ahead, go ahead. What did you put down? One more character? Yeah. You could mix up characters and numbers for each slot. Can you imagine? You've got 26 and 10, so you've got 36, 36, 36 everywhere. You can do whatever you want. As long as you end up with more codes, you win, right? So, example, add a character. Example, if you want to make sure that everybody understands what you're saying, right, this is 26 times 10 times 10 times 10 times 10 times 10, which is 26 times 10 to the power of 5, which is 2,600,000 codes. Okay, anything like that, if it says explain or anything like that, you may write something and have an example to strengthen your case. All right, how many marks is this out of? It's out of 9. It's out of 9, this page. Okay, and then we're going to go to the back side. Okay, John is planning a trip from Winnipeg to Calgary. There are 3 roads from Winnipeg to Regina and 5 from Regina to Calgary. Assume that he can travel along the road only once. So let's do a visual here. So we've got from Winnipeg to Calgary and then to Regina. And so, wait, Winnipeg to Regina. There's not even a machine and I'm still getting it wrong. What's your excuse now? Where's my book of excuses? I gotta have new ones. Anyways, 1, 2, 3. And then Regina to Calgary, 1, 2, 3, 4, 5. Okay, so that's it. Determine the number of ways John can travel from Winnipeg to Calgary. So you got to go from here to here. The assumption is we got to go through there. And so this would just be 3 times 5, and that's just 15 ways. That's it. As easy as that. The number of ways to go from Winnipeg to Calgary, then back to Winnipeg, so round trip. So we would go 3 times 5 times 4 times 2, right? So you got to kind of imagine you're going back where you used to have 5, you only have 4. Where you used to have 3, you have 2 now. So this would be 15 times 8, that would be 120. This is how we'll mark this one because it's a 2-mark question. I'll give you 1 mark for the first and a mark for the second, meaning if anything is wrong with the second, you lose a full mark, okay? Next, determine the number of ways the letters in the word confused can be arranged. So you count 1, 2, 3, 4, 5, 6, 7, 8. 8 letters. And 1, 2, 3, 4, 5, 6, 7, 8. So it'd be 8, 7, 6, 5, 4. And today we're going to introduce factorial so we don't have to do this nonsense. That's 40,320 ways. Okay? 1 mark for that. April and Jim and 3 other friends want to take pictures. Did I teach you that? Yeah, I did do pictures. Yeah, okay. 3, so 2 and 5 others, so 3 others, which is 5 in total. So arrange for a picture. It's just 5, 4, 3, 2, 1, and that's 120 ways. How many ways can the group be arranged if April and Jim are to stand on either end? So you can split this into 2 cases where you've got April here and then Jim there and then flip them, right? So if you did that, that's fine. But I will say you've got 2 and 1. This could be April, Jim. And then when you select one of them, you basically just have 1 left here. And so now you've got 1, 2, 3, 4, 5. Why do I have 6 lines? Sorry about that. There we go. So April and Jim. And so I go 2. You've got 2 options for this slot. You put one of them there, you'll have 1 left to fill in the second slot at this other end. And then you're left with 3, 2, 1. The 3 other friends to fill in the rest of those slots. So this would be 6 times 2 is 12 ways. Okay, I think this one, honestly, if this confuses you the way I just did that, break it up into cases. So for example, where you have 1, 2, 3, 4, 5, let's say you put April here and Jim there. So it's 1, 1, and this is 3, 2, 1, right? That'll give you 6. And then you do another case where you have Jim up here, April back there. This is 1 and 1. and then it's 3, 2, 1. That is 6 also, right? Combined gives you 12. Sorry, it's very small. I should have probably given that the main stage, and this one the smaller size stage, right? But regardless, you get 12. So break it down into cases if you have to. That is fine. But make sure that you know that they can be swapped as long as they're on either end. If they restricted it to saying April has to be on the left and Jim has to be on the other end, then it would just be this one scenario, right? But since they don't restrict it, you have to consider both cases. All right, last one. Multiple choice quiz with 5 questions, 3 options each. Jay says it's 125, Kayla says it's 243. Who is correct? Well, let's do the checking here. 5 questions. It's basically 3 to the power of 5, and that is 243, right? So Kayla is correct. Okay, justifying your answer means like, show me why, right? This is why. It's good enough there. Bonus. How many ways can you answer and get at least one question right? And here, the answer to at least one right is, again, I'm going to do this. Universal is, there's 243 ways to answer. This is the at least one, and this is none. Out here is like, all of these options out there is getting none of them right. Thought there was trouble. Okay, anyways, so what I will do is none right. How would you do none right? 1, 2, 3, 4, 5 questions, right? Every one has 3 options, right? I should stop saying right all the time, because how many are wrong in the first question? 2 are wrong, right? 2, 2, 2, 2. Every question has 2 wrong answers and 1 right answer. So the way to get all 5 wrong is to go 2, 2, 2, 2, 2. It's like Pizza Hut line, right? And that is 32. So we're going to go 243. That's all of our options and ways of answering, minus the 32 cases where you would get every single question wrong. That would be 241 ways. No, 211, sorry. That can't be 41. Sorry, 211. So you get a bonus if you got the 211, but you got to make sure you show me some work there. Don't just ask ChatGPT for that one, right? This backside is worth 8 marks. And of course, you can get 9 out of 8 if you got every single one right, including the bonus. So 8 and 9 is 17.